Welcome to your third lesson in polar coordinates. And this particular lesson, we've done graphing, we've plotted points. Now we are going to get prepared to go back and forth between the rectangular system and the polar system. So we have to set up some things first. And a lot of this you already know. So if you look at what I have on the screen, let me zoom in just a little bit. You can see that I've drawn a good old triangle. I know you're familiar with the triangle and with the rectangular system, but if we have the unit circle and we are in the rectangular system, you know that cosine, this would be a unit circle, right? That the cosine theta is equal to x, we always made the cosine x, or x over 1, because we have the unit circle, okay? The cosine of theta would be adjacent over the hypotenuse, right? And that we would say the sine value is equal to our y over 1, or the opposite over the hypotenuse. Well, if you're dealing with, let's just do this little point right here. We have an x and we have a y. When you're in the polar coordinate system, polar points and equations, the r will vary, right? Here, r is a real number. So it's not just 1. And when you have the same point here, we are going to call that x. Here we would do cosine would be x over 1. Well, now we're going to say cosine of theta is x over r, is whatever the radius is. And you know this point to be cosine theta sine theta. In the polar system, we know that point to be r theta. Right? Here we know that sine theta is used to y over r. Now if I cross multiply, put that cosine over 1, cross multiply r times cosine equals x, then x equals r cosine theta, and y equals r sine theta. Now look what we've done. We are now created a way to go from the rectangular x and y to the polar. So these are very important for you to memorize. Okay? And it goes right back to your triangle. You know those. You also know that if I look at this Pythagorean theorem, this now, my hypotenuse, my radius, is equal to the x squared plus the y squared. And if I want to get to just r, that would be the square root of x squared plus y squared. And sometimes we're going to need that as well to go back and forth between the two systems. When I say back and forth, I'm meaning to go from, let me get a different color here, to go from rectangular, okay, to more polar. And sometimes you'll go back from polar to rectangular as well. Sometimes you're going to want to play more with the theta. You're going to need to know theta. Well, let's look at this triangle. You know that theta, tangent of theta, would be sine over cosine, or y over x. Right? Tangent of theta is sine over cosine, or y over x. And if I want to find theta, I need to do the inverse tangent. Right? Inverse tangent, you remember when we did this? Of y over x. Now remember that we were also restricted where that existed. So we need to remember that that is true only in the area from negative pi over 2 down to pi over 2. Remember, it was only existed on the right-hand side, quadrants 1 and 4. Okay, let's write that down. In quadrant 1 and quadrant 4. Now that is true if we have a positive x. Think about the quadrants 1 and 4. X is positive. Okay, so this area right here, let's just say if x is greater than 0. All right. So if, I know this is going back to remember chapter 4, but you can do this. Remember, if theta is in quadrant 2 or 3, what did we have to add? Do you remember? All right, we had to add pi or 180. I don't care which one you use, because we had to kick it around to quadrants 1 and 4. So we use this. If it's going to land in quadrant 2 or 3 and we have to add this, this will happen if x is less than 0. Think about it. In quadrant 2 or 3, you have the negative x, negative cosine. So you have to add. That will help you if you remember that you're adding if it's going to be negative. Okay? So what I'd like to do now is to practice, start first with the points like we did when we did the graphing. 9-1 was just basic plotting of polar coordinate points. So let's do that first. Just play with the points and then we'll go to equations. So the points, we're going to do that first. Here we go. If we go from polar to rectangular, okay, if I give you an example of example 1, here we are, -6, -120 degrees. So there's my r, there's my theta. And I want to know the rectangular point for this polar point. Well, it's not that hard. If you know that this is r and you want to, and you have the theta, just keep in mind that you want to get to the rectangular. You want to get to the x and the y. So you have a substitution that uses the x and the y with the r and the theta. And you have an r and you have a theta now. So you're going to plug them into these equations. These are very, very important equations to remember. So here we go. We are now going to have x, let's pick a color, Mrs. Reams. All right, x equals the r, which is my -6, times cosine of my -120. My y equals my -6 times the sine of -120. Now we're going to go through, obviously you got to go back to your unit circle and you're going to pull these out. So this is going to equal -6 times -120. Or positive 120 is in quadrant 2, -120 is in quadrant 3. I'm down to the -1/2. My answer is 3. Y, -6. All right, again, -120. I'm down in quadrant 3, so I'm going to have negative square root of 3 over 2. 2 into 6 goes 3 times, so, and I have negative times negative, so I have a 3 on the root 3. So that is my answer, 3 and 3 on the root 3. I have now found the rectangular equivalent to that polar point. Okay? Now let's try going the other direction. Let's try going from rectangular to polar. So keep in mind, you want to go to some r and some theta. example. Example 2. I'm going to give you the point 8, 10. And I would like you to give me what polar value that is. Now, keep in mind, I'm going to look at the 8 and I'm going to remember, okay, 8 is positive, so when I'm trying to get to the theta, remember when we talked about the tangent? It's probably going to already be in those quadrants and I don't need to worry about it. Okay? So I'm not going to have to add and spin around and add 180. Alright, so I want to get from x and y to r. I'm going to use this right here. R equals the square root of x squared plus y squared. That's another very important one that you're going to want to remember. Here we go. So I have r equals the square root of 8 squared plus 10 squared. That is the square root of 164. So r is about 12.81. And depending upon the directions, if I say exactly, all right, there you can leave it as the square root, simplify it. But right now we're going to go to decimal. All right. Now we have to play with the theta. The theta is the inverse tangent, remember, of the y over the x, of the 10 over the 8. Well, that's 5 over 4. So I can figure out the inverse tangent at 5 over 4. Where does that happen? That happens here at 0.896. Sorry about the lights. There we go. Okay, so I have the point 12, the R point would be 1281, the theta would be 0.896. Now, as you know, that is a polar point. So I could add 2 pi to this, and I could, all right, if I add 2 pi, I can spin around. You're used to this. We did this in the first lesson. Remember all the numerous ways to different polar coordinates? So I could have 12.81 at 7.18. That's also a value. Okay, if I just want to add pi, then I need to take the negative of the r, and I would have negative 1281. Okay, if I had 4.04, that was if I added only pi. I want you to remember that, all right, I'll box this one, but this is going to have one exact answer. When you go to rectangular. When you go to polar, you're going to have numerous answers. All right, so you can have many different ones, but this direction, there will be only one right answer. Okay? I would like to give you a few calculator hints. You're not going to have your calculator to do this, but your calculator will go back and forth and does this conversion for you. The points we will select will be points that you know from your unit circle. For example, you did not know the inverse tangent at 5/4. We will give you points that you know on the unit circle. But when you come back in the second video and before we do the equations, I'm going to give you some calculator tips right here. Okay, very quickly before I close this video out. In the calculator, if you go to second angle, it's the apps button. Let me show you where that is. It's right here where it says angle, apps. You can't see that, can you? Right here, apps. So we're going to hit second angle, and you'll see as you scroll down, you have options. You have options to go from R to PR, well that would be rectangular, to the polar radius, or the rectangular to the polar theta, or P to RX, that would be the X of the rectangular coordinate from the polar. And you would select those and you enter the point, and it will do the conversions for you. We want you to do this with the math and with the unit circle, so you will not have a calculator for these assessments, but please feel free to use it to check your work. All right, I'll come back shortly with the next video.